much background noise, I might mute people just because it's easier for me to focus that way. Because I lose focus easily. But we are in week 12. We're doing a lot of equation solving. Ooh, Jonas Brothers. Yeah, they both married some really cool people. Notice that. Okay, so we're doing equation solving today. Lots and lots of equation solving. These are your assignments today, or this week. I kind of already showed you. You've got equations with variables on both sides, equations with fractions. There's a number flexibility quiz, and then your test. So today, we are going to first review solving equations with variables on both sides. Then we're going to talk about how to deal with equations that have fractions in them. And then I'll show you a really cool trick of how to cancel out fractions. And then we probably will not get to the partner activity because of time. But hopefully we will, but we probably won't.
Because y'all be talking.
Yeah, but that's okay. That's all right. We did not get to it yesterday just because we were still on the equations. Well, highly recommend you guys have a piece of paper and something to write with to take just some examples of these equations down. The more examples you have, the better off you are. But you guys know what works for you. So this is a review from what we did last week a little bit. First step when you're solving equations will always be to simplify each side of the equation by using the distributive property. That will always be your first step. If you see parentheses in the problem, distributive property. That is your first step. And then your second step will be to combine like terms on each side of the equal sign. Ooh, Overwatch. Yeah, my son likes collecting guns from that game. He does. So yeah, those are our first two steps. Simplify by distributive property and then combine like terms. And then step 2 is solving like a two-step equation. So you're going to get rid of your constant and then get rid of your coefficient. Constant always goes first. Yeah, and it looks like someone likes my suggestion of drawing kind of a wall in there under the equal sign. And that's what I like to do first because it helps me see. Oh, that's cool. Very cool. Blizzard. It's a Blizzard game, right? I used to play World of Warcraft. That's cool. Corn and bagels. Nice. Hey, good stuff. Sometimes it's just whatever works, you know? I'm going to let my spaghetti get cold because it's too hot. Too hot.
Oh, I thought you were going to let it get like cold and then eat it.
No. Yeah. It's an unfrosted donut. Guys. Aged cheddar. Ooh. Num num. Okay, I'm going to pause really quick. I have a lot of friends who like to work ahead in here, and that's awesome. So awesome. But I'm going to pause you real quick. I'm going to pause 1 second because we want to make sure that the steps that we're showing are the right steps. We want to make sure of that. And that's, you know, like I said, I applaud it. But if I want to take a minute and give you some hints there, I will. So before we tackle that constant, because you're not wrong. It looks like the person was trying to get rid of that 4. You totally can. But we want to stick to doing that distributive property first. What will I distribute? Yeah, look at that. Look. They're saying distribute the negative. Yes. So what we would actually do is almost write in a -1 in front of that. Well, that's a plus sign, right? Yeah. In front of that parentheses there. So if you have a problem and there is a minus sign with no number in front of parentheses, draw a 1 in there, because what you're actually distributing is either the negative sign or a -1. So let's distribute that. What would you get after you distribute a -1? What would you get on there? Yup, you get a -y. That's good. Plus looks good there. And then remember, we're distributing that. Yeah, -9. Yeah, look at that, because we're going to multiply -1 times the y and then times the 9. Oh, that's good. Let's focus the chat in the chat there on the problem, just so we can get it done and then move on to talking about fun stuff. So we distribute the -1. That's very good. And this is what we have. And then we would just bring down that 4 and that 16. Good. So we've distributed. Now what? Now what do we do? Hi, Silver. Oh, Silver wanted to say hi. Here's Silver. There's my kitten. My baby boy. He's going to the vet tomorrow to get neutered.
He looks like the cat from Pet Cemetery.
Oh, yeah.
Do we combine like terms?
Yes, we do, Connor. That's good. And it looks like I have someone who's subtracting 4, and that's okay. You can do that. But I'm going to stick to what I'm showing you on the steps there. So instead of subtracting 4, although you're not wrong, technically that is correct. Hey, buddy. Hey, buddy. Technically that is correct. What we would do first is combine some like terms. So we're going to combine the 4 and the -9 because they're both numbers. They're both numbers there. So what would they combine to equal? 4 and -9. 4 and -9. I don't know if it would be 8, because that's like saying I have $4 and I owe you $9. What is that? If you have 4 but owe someone 9. Yeah, Connor, very good. -5. You're totally right. Yeah, so we would bring down the 16, and then we would have -5 here minus that y. Yeah, do you guys see how that's -5? See where we're getting that from? We combined the 4 and the -9, and we got -5. So now we want to get rid of that constant, because we did our distributive property, we did our combining like terms. Now we're going to get rid of the constant. What number is the constant in this equation? What number is the constant? Not 16. It is a constant. You're right, but it's not the constant that we're going to get rid of. Which one are we going to get rid of?
-5.
-5. Good. We got to get rid of that -5 because it's on the y side. So what's the opposite of -5?
+5?
+5. Yeah, or 5. So we're going to add 5 to both sides. And I see someone putting a plus sign here. It looks like someone was saying you would just do +5 like that, and that's okay too. That's fine. It's up to you. If that's how you were taught to do it and that makes more sense, you go for it. That's good. So then we'll have 16 plus 5. What is that? 21. And then it equals -y. Oh, on the board there. Yeah, that's good. That was right. That was right. So now we have 21 equals -y. What do I do there to get what 21 equals? Hey, buddy. How do I get rid of that negative in front of the y? Yeah, you could just kind of slide it over. You could either say, well, if negative y equals 21, then positive y would equal negative 21. Yeah, that's cool. You could just slide it over. Mathematically, what we're doing is we're dividing by a negative 1. Because negative y is just like saying negative 1y. But it's okay if you just kind of reason it out. That's cool. Oh no, Cece. She gets the sneezes. Oh no. Cool. Any questions on that? You're allergic to live sessions. Oh no. Where you see my kitty cats. I sleep. Are you sleeping? No sleeping.
She might be allergic to people
Oh no. Or the computer.
or virtual people.
Uh-oh. Yeah, I'm allergic
I
to
don't
like
like going
everything outside.
so I'm allergic to people.
I'm with you. Okay, so now switching gears, we got to talk about equations with variables on both sides. Oh yeah. Hey, that's the beauty of online school, and a lot of stuff is online, so you can be an introvert. It's all good. So first step remains the same. First step is always distributive property. And then your second step is going to be combine like terms on each side of the equals. Then after you combine like terms, after that, then you're going to get variables on the same side by doing the opposite. You got to cancel out the whole term by adding or subtracting. Then you're going to get rid of that constant and then the coefficient. So let's do the first one here. Do I have to do the distributive property in that one? Callie, I'm jealous. That's awesome. Do you have to do the distributive property in that one? Yeah, Ben, you're right. No, you don't. No distributive property needed. What about combining like terms on each side of the equals? We would actually say no to that, and I expected some people to say yes. I did, because there's two z's. But on each separate side, on this side, we don't need to combine anything, and on this side, we don't need to combine anything. So that one, we don't have to combine anything quite yet. So, sorry, I got rid of the line. Can someone put the line back in there? Sorry. I ruins it. Oh, no. Thank you. Thank you. Thank you. Okay, so we're going to skip, right here. We're going to get variables on the same side, and we're going to pick on the smaller one. So
Bully.
we're going to, I know, I'm going to be a bully and pick on the smaller variable. Which one's the smaller variable there? Five Z. Yeah, 5Z. We're going to pick on that one. So we're going to do the opposite of the whole thing to move it to the other side. What's the opposite of positive 5Z? Yep. You know, this person's dividing. They're saying we would divide, and that would get rid of the 5. It wouldn't move the whole 5Z. We actually want to subtract it.
I thought you said positive vibe, and I was going to say the opposite is negative vibe, but that would have been wrong.
You're right, though. You're not wrong, though. Like, if we have a positive vibe there, the opposite is a negative vibe. It cancels it out. Why are you scratching me? What did the 5Z do to you? Everything. Aha. No, I'm just kidding. So we picked on the little one, picking on the little guy there, and now we're going to bring everything down. We're left with 1Z plus 17 equals 8. That's so mean. Now, it took Logan. Logan's at school. Huh. Logan is my son, and he is a presence. He likes to be known to my students and all that. But yeah. Okay. Along with my daughter. Opposite of blue. Ooh, that's a good question. Mathematically, yes, that's how it would work. Mathematically. Yeah, that's the definition there. But in art, it would be a little different, probably. So here, because language arts has a different way. It's like a negation or a contraction. So instead of does not. That would be the English opposite. So a negative is like an English contraction or something. I'm trying to get a little too deep there. Stop it, Jen. Stop it. Okay. So now let's get rid of that constant. What number is the constant here? Yeah, looks like someone's going to get rid of that 17. That's what we want to do. We're going to subtract 17 from both sides. Good. Good stuff. And then we bring down what's left over. Could I just say z? Do I have to say 1z? Yeah, you can just say z. I like that. Z is what's left. And it equals, and this cancels, 8 minus 17. It is not evil. Negative 11. Good job. Very good. Actually, negative 9, right? No. No, it's 11. Wait. That doesn't seem right. Why does that not seem right here? 17 minus 8. That's 9. Yeah, negative 9. I couldn't think it through. My goodness. It would be 9. I'm adding mine in there. Small brain. No, we all have big brains. Big brain. Okay. So let's do the next one because that looks perfect. Very good. Next one, we got to simplify each side, distributive property, and then combine like terms. Which one of those do I have to do? Is whiteout edible? Which one of those do I have to do? Distributive property or combining like terms? Because there is one of them here. Ooh, someone says it's going to equal 7. Okay. Yep. Someone's writing distribute. That's very good. Good stuff. So I'm going to distribute that negative 3 by multiplying. Good. What do we get after we distribute? Okay. All right, Ben. Let's see. What are we going to get after? It looks like it's saying that after you distribute, it equals that side. It totally does, but no, they're setting up the equation that way. So we're going to distribute on this side. We're going to go negative 3 times 6. And then remember, every minus could be changed to adding a negative, just as long as you see that 2x is negative. So then negative 3 times negative 2x equals 2x plus 10. So now what do I get when I simplify the other side? When I simplify after I've distributed. What do you get on the left side? I love that you guys are taking bets. That's awesome. Oh, don't write IDK. No. So we did the distributive property. Now we're going to simplify right below. No writing on the board, guys, unless it's like relevant to what we're doing here. So we distributed. Now we're going to simplify. We get negative 18 plus 6x. Right? Do you guys see that? We just multiply it out. All right, Callie, you are cool. Does that make sense so far, guys? If it makes sense, please type yes in chat. Okay, good. Maybe. All right. Yeah, it's steps. Yeah, sometimes it takes a bit. It really does. So we distributed. If we had to combine like terms, we would do that now, but we don't. Now we're going to get the variables on the same side. We're going to pick on the smaller one. Again, which is the smaller variable there? I'm cold too, Callie. It's a chilly day over here. Which one of those? Yeah, 2x is the smaller one. You guys are right. So we're going to do the opposite of positive 2x. We're going to subtract 2x. And that leaves us with negative 18 plus 4x equals 10. Notice, guys, when I subtracted 2x from each side, I put it right under the variable term. Otherwise, it gets really confusing. Okay, now we got to get rid of that constant. Hey, side business, right? YouTube. Now we got to get rid of the constant. What number is the constant there? Negative 18 is, yeah. So we're going to do the opposite of that. What's the opposite of the constant? Yep, we're going to add 18. And sometimes you might not need to put it in there like that, but I usually do. So that's going to cancel. We're left with 4x is equal to 28. And then what do we do to get rid of that coefficient? Cece, you're hilarious. I love it. What do we do to get rid of that coefficient, which is 4? What we do? If we're already multiplying x times 4, what's the opposite of multiplying by 4? Yeah, we would divide by 4. Totally right. Very good. So x is whatever 28 divided by 4 is, and dun, 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 it is 7. Very good. Good stuff. Yeah, same here. I has no money. Good stuff. Good job, guys. Does that make sense?
I believe so.
Okay, good.
I do not have big brain, so.
You do have big brain. We all have big brain. Let's do this one. This is a good one. Oh yeah, this is a good one to write down. It's not really. I don't know. If you follow the steps, it's all good. I has microbrain. Me too. On days like this where it's cloudy and gross. Okay, so we've drawn our wall in there. I like our little emoji dude there. First step is to distribute. Nanobrain. What are we going to distribute? What number? We're going to distribute to the 2x. Yes, we are, definitely. What are we going to distribute to the 2x? Yeah, someone wrote the 3. Very good. Very, very good. Yes. So yep, and it's good to circle your variables and be aware of that. That's very good. That's good too. So we'll bring down the negative 9x, and we're going to distribute the 3. Whatever is right in front of the parentheses is what gets distributed. You know, I'm okay with that, like for thought processes, because I like it when people write on the board. Remember, if you write on the board, I can't really tell who it is. I don't have that turned on. So you can kind of safely answer that way if you ever don't like being wrong in front of people. Me, I'm used to it. I had an awesome middle school principal when I was teaching there in a brick and mortar school. Oh, that's okay. No problem, Isabel. And she used to like rip me a new one with how I viewed my lessons and this, and it was honestly a really good thing. It was. So it's helpful to take critiques like that. Oh no, it's all good, Isabel. Blue is dark, yeah. This is CC. Look at, I have my cool pen. Can write real nice on the screen. Here's mine. I love that. I love this pen. It's so cool. All right, so we distributed the 3. That's pretty good. For drawing with the mouse, that's awesome. So we're going to distribute the 3. We're multiplying to each term in the parentheses. Remember, every minus can be changed to adding a negative. So plus 3 times negative 15 equals negative 19 minus 2x. Good. So you distribute what's right in front of the parentheses. Now let us simplify. So negative 9x, what's 3 times 2? X there. What does that simplify to be? 6. Yeah, 3 times 2x is 6x plus 3. Oh, I wrote 15. I think I unconsciously did that in my head. It's supposed to be a negative 5, but 3 times negative 5 is negative 15. So that was our first step. That was the distributive property. That's done. Now we got to do second step. We got to combine like terms on each side. So what do I get when I combine like terms on each side? Guys, whoever's doing this, I'm going to encourage you to not do that, because I guarantee you people are watching that instead of the instruction, because I totally was, because that's really cool. So what do you get when you combine on this side? What do you get there? Yes, negative 3x. Very good. I said that really loud. Sorry. Plus negative 15. Okay. So second step is done. Now we got to get our variables together on the same side. We're going to pick on the smaller one. Which one's smaller, negative 3x or negative 2x? Remember, with negatives, it kind of works opposite, right? As the negative number gets bigger, it's actually further away from 0. So yeah, so that minus 3x is bigger. So we're going to do the opposite to that to move it to the other side. What's the opposite of minus 3x? Plus 3x. Yup. Very good. I like how this person in red wrote it. Yeah, that's neater than mine, but sometimes they disappear, so that's why I wrote it. So we add 3x. So this cancels. We're left with negative 15 equals negative 19. What's negative 2 plus 3? What would that be? Negative 2x plus 3x. Yeah, it's just x. 1x. That's good. Yeah. Yeah, agreed. Very good. So that's 1x left. Good. Or just x. And now I got to get rid of that. That's good, Isabel. I saw that. Now we got to get rid of that constant. Which number is my constant? The negative 19. Yeah, this is a constant over here, but since it's not on the x side, then we wouldn't call it our constant. We have to get rid of. So what's the opposite of minus 19? Yep, we're going to add 19 to each side. Very good. So once you add 19 to each side, what do you get then? This is going to cancel. We're left with x equals what's negative 15 plus 19? 4. Good. Good stuff. And we don't have a coefficient to get rid of here, so we don't need to do this step. Yeah, that's very good. Any questions on that? So as you're sitting and listening to this, okay. I'm looking at what, it's okay. Nope, it's good.
Why don't you type it in chat?
No, hey, it's all good. See,
Okay.
with chat, it's yeah, you're very good at that. Whoever's writing that's pretty impressive. Sometimes it's nicer to write on the board because then I can't tell who it is. So sometimes people like that anonymity or being anonymous there.
Someone write oof really small.
Oof, I like that. Okay, so now someone wrote that they didn't get it, and I get that. I totally do because is it snowing?
Oh wait. Oh, I should send a picture to my computer and show you guys because it is insane. Oh yeah, no, Ben is in the same area. That's what it looks like.
Yeah, it is not. It's rainy and like 50 degrees over here.
We got like at least 3 inches at bare minimum.
I am in Wisconsin, so yeah.
Wisconsin. My favorite football team's there. I mean, Ben's not gonna like me no more.
Uh-oh.
I don't like football, so don't worry.
Okay, sweet.
Yeah, I'm not a big football person, but yeah, there's a lot of rivalry there. Yeah, it's 53 out today. So it's crazy. So, okay. Someone wrote that they did not get it, and I get that because there's
I kind of feel on the same page.
There's a lot of steps there are. So now I'm going to ask, clarification if you don't get it, if it's just like, if you have a question, I want you to ask, but if it's like kind of the whole thing, it wouldn't be me, Aiden, I know. But if it's like the whole thing, it might benefit you from rewatching this and watching the steps again, or meeting with me, and then I can help you with it. So just keep that in mind. If you're just not sure, and if you want to meet, you can even stay after a little bit from our live session, and I can go through a few problems with you. Okay? But if you have a question, I will answer it right now. So just kind of going through our steps, we first distributed. That was our first step. Then we combined like terms. Then we got the variables on the same side. Then we got rid of the constant. And for us, that was enough to solve it. Just to get rid of the constant there. Sometimes you got to divide and get rid of the coefficient. So guys, person who had trouble with that one. Oops, I stopped sharing. Sorry about that. Okay, there we go. So person who had questions there with that. No, watching the TV. Did you have a specific question? Or go ahead and type on the screen if you're just a little unsure. Okay, so no specific question, but keep in mind that no, I'm not giving. Ben, did you request remote control? No, Ben. Sorry. No, I'm not giving control of my computer over. That's really funny. You guys are the best. But yeah, if you have issues that you just want to meet together, keep that in mind. Let me know. Okay, we're going to talk about this one. you will see a question like this pop up in your homework. How on earth do you guys think we could tackle solving this problem? Do you guys remember how to do this? A problem that it might look like is something like this. Right? I know. No, don't give up. So it might have looked something like that. Do you guys remember the process? Not keep, flip, change, although that is logical, seriously. Do you guys remember that? Yeah. Oh, Dawn is calling me and I'm in live session right now. Yeah, I know. Okay, I'll call her back. I'll call her back. I'm gonna message her there and say, oops, probably shouldn't show you guys my conversations with Dawn there. Hi, Dawn. I'm in live session, almost done. Okay. Secrets, right? Not really secrets. No, you'll see her. You'll see me messaging her in a meeting saying, what's going on here?
Is confidential.
Sorry, not sorry. It's all good. It's all good. She's texting back her response. Okay. I'll tell you what she says. Maybe. Okay, call me when you can, she says. You got it, Dawn. All right. So we are totally going to cross multiply. That's exactly right. So I just want to bring it up. When you have this one in your homework, you're going to cross multiply. But you're going to use parentheses around the expressions. So 8 times x plus 1 equals 7 times x plus 8. So your first step there will be to cross multiply, cross product, right? Then what would I do? What would the next step be since there's parentheses? What is that step? Zook, oh, that's funny. That's interesting. Okay.
Pronounced Zuck.
Zuck, okay. Interesting. All right. What would I do now? What would I do now here, guys? What's that property? Someone wrote PEMDAS. I would distribute. Yes, very good. That was a mixture of yes and very good. Yes. But we would distribute. Yep, you get 7 times x. Good. Good. Yeah, and it looked like the person here was gonna just put 8. Maybe they're gonna put 8 times 7. That's totally possible. But just don't forget to distribute to both sides. Good. And then what would I get on the left side there? Because I got to distribute both sides. Looking good. So we're going 8 times x plus 8 times 1. Good. Then underneath that, I would simplify. And I'm going to do it on the side over here just so that there's more room to write. Person down there, keep writing. You're doing good. So we would have 8x plus 8 equals, yep, 7x plus 56. Good. Now I got to get those variables on the same side. I'm going to pick on the smaller variable. So which one's smaller? Which one would I get rid of or slide to the other side? 7x. Yup, you're right. So it's positive 7x. So I'm going to do the opposite to move it to the other side. So we're left with x plus 8 equals 56. Now I want to get rid of that constant. What do I do here? We're almost done. Come on, guys. Stay with me. What would I do here? What's the opposite of my constant? Yeah, I would minus 8. Yep. I would subtract 8. You're right. So my answer is whatever 56 minus 8 is. What's 56 minus 8? Is that 48? I think it's 48. Yeah, very good. Good job. Hey, you were. Any questions with that one? So we would cross multiply and then solve per usual. Okay, I got to show you two more things, how to deal with these equations that have fractions in them. Oh, and you know what? You are always allowed to use your calculator. Always. It's okay. Totally fine. But I just want to make sure you know the process. Okay? Cool. Okay, so if you have fractions.
I almost tipped a jar of pepper.
Ooh, don't do that. That'd be spicy. Too spicy there. Okay, so if you have fractions in your problem there, okay, you're still going to get rid of the constant by doing the opposite operation. Don't forget that you need common denominators if you want to add or subtract fractions. You also have Desmos. I will show you how to do that. And then this one's kind of new. Get rid of the coefficient by multiplying by the reciprocal. Does anybody know what a reciprocal is? Okay. What is a reciprocal? Yeah, it's where you flip your fraction. Good. Okay, so let's solve this two-stepper here. So I'm going to get rid of my constant, which is 7, by doing the opposite, right? He does. So we're going to subtract 7. So we're left with negative 1/4 times x equals -5. Now, how would I, if that was just like a -4 times x, what would I do to get rid of multiplying by -4? What would be the next step here that we've been used to doing? What's the opposite of multiplication technically?
Desmos should be the god of math.
Right? Division, yeah. So, and you can still do that here. So let's say that you forget about multiplying by the reciprocal and you divide by -1/4. Now that might look crazy, -5 divided by -1/4. But remember, we are friends with Desmos, the Greek god here. So if we go to Desmos, it's desmos.com/scientific. I will put that link in chat.
Desmos.com.
It's pretty awesome there. So we're gonna enter in. We're gonna
I didn't
go.
know my mic was on.
That's okay. We're gonna go -5 divided by. And then see how you can type in that fraction here. You can go -1/4. And
Fraction
it tells
of a
you,
fraction.
right. So it looks crazy. Oh, it's not Domino's. That's funny. It looks crazy, but you'll see it. It'll still work. It will. So it's pretty cool. So now what you would actually do mathematically is we would multiply both sides by the reciprocal of -1/4. What is -1/4 flipped? Now I want pizza. That sounds really good. What do I get if I flip -1/4? You gotta flip it. Not cows. What's negative 1/4 flipped? 4/1, yeah. And I would still leave it as a negative. So we don't want the opposite reciprocal. We just want the reciprocal. So we would leave it as negative 4/1. And then we multiply straight across. That's where you get x is equal to 20. Desmos is a really helpful thing here. So even if you have a problem like this one, guys, see how if we want to get rid of this constant, this 1/5, if we want to get rid of that positive 1/5, technically, guys, we would need a common denominator there, right? In order to do that subtraction. So we'd have 3/2 x equals, technically you would need a common denominator. But if you don't want to waste time with a common denominator, you can use our friend Desmos. So we can go 3/4. You can just enter it. 3/4. Oh, you got to be careful how you type it in there. Minus 1/5. And look, it shows you 0.55. You click on the little circle thing there, and you can see you get 11/20. Okay, does that make sense, guys? Use Desmos. Guys, make sure you know how to do this. This is homework you'll have to do. And then we can multiply by that reciprocal. Nope, we're not talking pizza. We're making sure we're good to go. That's okay. We multiply straight across the top, straight across the bottom, and you get 22/60. Uh-oh, I can reduce that, right? What do I divide by to reduce that? Don't type IDK. Think about it. Well, they're both even. They're both even. So since they're both even, you could divide by what number? Oh, someone wrote it right there. Yeah, very good. I'm like thinking someone wrote a date or something. That's good. Yeah, so if you divide by 2, you do get 11/30. Good. Right. I know. I like that. No IDKs, because that doesn't help. Okay, last thing I want to show you guys is how to multiply by the lowest common denominator. Okay? So if you look at all these fractions, what would be a common denominator between those? 3 and 6. What's a common denominator? What could all of those denominators? Yeah, 6. If I multiply the whole equation by that common denominator, I can get rid of the fractions completely. It's pretty cool. So if I multiply everything in there by 6/1, so I go 6/1 times 1/3 x minus 6/1 times 5/6 equals 6/1. So if I multiply everything in there by a common denominator, it's going to get rid of those fractions for me. So what's going to happen here? 6/1 times 1/3. That's, if I multiply straight across, that gives me 6/3x. Multiply across here, you get 30/6. Multiply across, you get 12/3. Yeah. And then when you divide those, you get 2x minus 5. Yeah, it's a neat little trick. You probably have seen it before. And then if you solve that equation, it gives you the same thing. So we kind of busted through this really quickly. If you feel like you want to hang around and see another example of it, please do. Otherwise, there's more instruction in the Moodle lesson. If you were my friend who was having trouble and just following all the steps and wants to work with me, hang out, let me know and we can set a time. But we are at time/over. You guys are free to go. That's all I got for you. You guys did a really good job. I know, right? If you want